So an organizational researcher was interested in whether individuals working in different sectors of a company differed in their attitude toward the company. And the results for the 3 people surveyed in engineering were 10, 12, and 11. So we had how many groups? We had engineering, we had marketing department, we had accounting, and production. So engineering. Yeah, I need to get. So engineering, marketing, accounting, and what's the 4th one? Production. Thank you. Okay, and engineering had 10, 12, and 11, and marketing were 6, 6, and 8, and accounting was 7, 4, and 4, and production was 14, 16, and 13. And the question is, was there a significant difference in the attitude towards the company among employees working in different sectors of the company at the 0.05 level? So if you just take a look at it, you can see that production is way out there compared to the others. But how far are they? How far is their mean from the other people? So let's do this. Let's do it together. You have to go through the 5 steps of hypothesis testing. However, you can sort of do the calculation ahead of time and then do the 5 steps. Everybody with me? So for the test, possibly the way I would do it is run the calculations and then go through the 5 steps of hypothesis testing. Everybody with me? Please feel free to ask. I mean, this is going to be definitely going to be on your test, on your final. So you should be able to do this. Okay, so here's engineering. Let's get their mean, x over n, which is 10 plus 12 plus 11 divided by 3 gives us 11. Their mean is 11. M1 equals 11. M2 equals 6 plus 6, 6 plus 6 plus 8. 6 plus 6 plus 8. 6 plus 6 plus 8, right?
The total was, the mean was.
Oh, yeah, the mean. OK, we still aren't there. 6 plus 6 plus 8 divided by 3 gives us 6.7. OK, now mean 3 is 7 plus 8. That's 15 over 3. 15 over 3 is 5. Wow, I didn't need to use the calculator for that one. 14 plus 16 plus 13 divided by 3 gives us 14.3. Okay, so you can see these are the closest. These are pretty far away from this one. And if you look at these guys, they're clustered around 11. This is clustered around 14. So we're looking at possibly a difference between this mean and this mean, right? And the question is this just normal variation when you sample 3 individuals from each department? Or is this significantly different? Are these means significantly different? And the way you would do it is what we've discussed before. You go through the steps that we've built up to the independent t-test. So the first step is to think about your f. What is your f composed of? Your f is composed of 2 things. And what we're looking for here is the observed f, in the sense that what is our f ratio built on these samples? What is the observed f? The f is made out of what? Exactly, the 2 variances, s squared between, very good, and s squared within. So our task here is to calculate s squared within and s squared between. And the easier one is to calculate s squared within, because s squared within is exactly what we learned when we were doing the independent t-test. The s squared within is exactly the same as s squared pooled, right? So how did we get s squared pooled when we were doing the t-test? We had a sample. We had actually 2 samples, right? In this case, how many samples we have? We have 4 samples, right? So, I could draw 4 samples. And here we go. Maybe this is outside the camera, but it doesn't matter. This sample has a mean of 11. This sample has a mean of 6.7. This sample has a mean of 5. And this sample has a mean of 14.3. OK, so how do we calculate the pooled variance from samples?
If they have an even number of scores, you can add them and then divide it by the number.
Perfect. So first step, estimate the population variance from the sample, and then just average them. That's the pooled variance, especially when the n's are equal. When the n's are equal, all you need to do is just average them. So the first thing to do is to take this variance and take the variance of this sample and estimate the variance of the original population from this sample. And to do that, what do we need to do? How do you estimate variance? How do you get s squared? Exactly. Find the variance. But what type of variance do we find?
T-test, the estimated.
Very good. The estimated variance. So the unbiased estimate of the variance of the population. And the unbiased estimate of the variance of the population is s squared, and we call it s squared 1, which is equal to the sum of squares divided by degrees of freedom 1, right? And similarly, the same for this one. So let's calculate the variance for this guy. I'm going to use a different color. So 10 minus 11 gives, so 10 minus 11, so you need to find x minus m, right? X minus m. 10 minus 11, this is your m, is minus 1. 12 minus 11 is plus 1. 11 minus 11 is 0. So you get a deviation score sum of 0. And then you squared the deviation, x minus m squared, 1, 1, 0. So you get a sum of squared deviations of 2. Okay, your sum of squared deviation is 2 divided by degrees of freedom. What's the degrees of freedom here? 2. N, which is 3 minus 1, which is 2, gives us a variance of 1. Excellent. So we found the variance of the first one. S squared 1 is 1. How about s squared 2? 6 minus 6.7 is minus 0.07. 6 minus 6.7 is minus 0.7. 8 minus 6.7 is 1.3, right? And supposedly this will sum up to 0, but it doesn't because of the fact that we rounded up. So we just square these, and we get the sum of squares. So 0.49 for this one, 0.49, 0.49, 0.49, 0.49. And sum of square, the square of 1.3 is 1.69. And therefore, the sum of squares of, so s squared 2 is equal to 1.69 plus 0.49 plus 0.49 gives us 2.67 divided by degrees of freedom, which is 2, gives us 1.3. Okay? It's 1.33. Everybody okay with me? Anybody got stuck on this? Everybody knows how to do this? Will you all be able to do it on the test? Okay. I'm trusting This is a yes. I hear very few voices. Yes.
As far as showing the sample, where do you want that? Can that just be on the side of the
Yeah, it could be on the side. You know, something for your own sake to really sort of start, you know, to help you remember what you're doing. It's nice to show the sample and keep track of it. So, and it also will give you more chances of getting a good grade because of the fact that if you show your work, even if you make a mathematical mistake, I'll still count it. You're showing me that you know the concept, so that's very important. So going to this one, 7 minus 5 is 2, 4 minus 5 is 1, and 1, or minus 1 minus 1. This gets you to a 0. So square these, it's 4, 1, and 1. So sum of squared deviations is 4 plus 1 plus 1, which is 6. So this is your sum of squared deviations. So s squared 3 is 6 over 2, which gives us a value of 3. So here we go. For this one, it is s squared 3 gives us a value of 3. So this is more spread. This is telling us that these values are more spread, right? OK, so these are spread. Now, how about this one? This one is 14 minus 14.3 gives us 0.3. 16 minus 14.3 is 1.7. And 13 minus 14.3 is 14.3 is minus 1.3. So 14 minus 14.3 is minus 0.3, excuse me. So you add these. This comes approximately to 0. Then you square them. So we are looking at 0.09, 1.7 times 1.7 gives us 2.89, and then 1.3 times 1.3 gives us 1.69, and then the sum of squares of these guys is 1.69 plus 2.89 plus 0.9 gives us a sum of squares. So s squared 4 gives us a 5.48 divided by 2 is 2.74. OK, so the last one would be 2.74. Again, here we go. S squared 4 equals 2.74. So out of these, this is the narrowest. This is and this is the broadest.
Incorrect on the 0.9. It's 0.09.
Sorry, say that again. 0.09. Thank you. Yeah, you're right. 0.09. 0.09. So we add these 0.09 plus. Sorry. Oh, OK. 2.89 plus 1.69 gives us 4.67. Yeah, 4.67. Divided by 2 gives us 2.34. OK, 2.34. Fantastic. So we've got all of these.